This video is on the properties and laws of logarithms. Let's look at some of the main ones. If you are adding two logs with the same base, you're able to change this into one log of that base with a multiply instead of the adding. Similar to that, if you are subtracting two logs with the same base, that is the same as one log with that base with a division of those two numbers. The one that comes after the minus sign is the one on the bottom of the division. The one that comes before is on the top of the division. Similar to that, if you have a log of something to an exponent, and this exponent would go to everything inside here, then that is equal to that exponent in front times log of that stuff that was inside. And when I'm saying you can change it from this to this, or this to this, or this to this, I mean both sides of the equal sign have an equal value. Okay, so these three here come from the laws of exponents. A couple of other important properties and logs of logs. If you are dividing two logs of the same base, then you can change that into one log, and what ends up happening is that the log changes to whatever number, the base changes to whatever number is here on the bottom. So if you divide two logs with the same base, you can write that as one log, and the base is now that bottom number. And then this is log base A of whatever was on top. This is often used in the opposite direction to change one log into two as well. Okay, and if you have a log written and they did not write the base, then it is base 10. This is not so much a mathematical property as a notation. This is the same way how if you just have an x, there's a 1 in front of that x, even though a lot of times we don't write it. If there's nothing written there, it's just because they didn't want to write the 10, but you should know it is 10. And finally, a quick review. You've already seen this in the previous video, but if you have log base b of m is equal to p, this right here is the exact same as writing b of p equals m. Okay, for the next part of this video, I will be proving these three logs are true. I'll show you how the proof goes. If you do not care about that proof, you are welcome to fast forward past that part. Okay, so in order to prove those three properties, first I'm going to have us review the laws of exponents. So if you have two with the same base multiplied together, then it is the same as that base, and then you're basically adding the exponent. So if you're multiplying two of them together, then it's the same as adding the exponents together. Okay? If you have exponent b to the a divided by b to the c, dividing these two is the same as subtracting the exponents. If you have b exponent A, and then that whole thing exponent C. That is the same as B exponent A times exponent C. Here, A, B, and C are just numbers. Okay, so that's a quick little review of the laws of exponents. Let's now prove some of those exponent properties we were talking about earlier. We're going to prove that very first one. So we're proving that if you have, if you're adding two logs together with the same base, that's the same as one log with these two numbers multiplied together. Okay, and to start off, let's say that we have, here all the letters are just numbers. So B, M, N, they're all just numbers. So if you have some number B to exponent E is equal to M, and let's say you have that same base, but to some other number F, we're going to say that's equal to some number N. Okay, so starting with that, we're going to create some other things it's equal to. So if this is equal to this, and this one's equal to this one, then these two multiplied together should equal these two multiplied together, which is all it says over here. So BF, B to the E times B to the F is equal to M times N. And I got this from there. Okay, let's simplify this using our logs of exponents. B to the E times B to the F is equal to B to the E plus F. All right, so now for these three, we're going to convert it into a log. So changing this to a log base B of M should equal E. And I'm just right now using this right here. If you have log base B of M equal to P, then B to the P equals M. B to the P equals M. Okay? So log base B of M equals E. Okay, same thing here. Log base B of N equals F. Okay, and doing that to this is be log base B of this M times N is equal to this E plus F. And I just wrote that down here. All right. At this point, what I'm going to do is I'm going to substitute. I know that E is equal to log base B of M. So I'm going to change this E for this. I'm going to change this F for that. So doing that, I get that. Okay, so I change the E to log base B of M, change the F to log base B of N. Right. And these two up here and down here are equal. All this happened is this log base B of M times N is just on the left-hand side instead of the right-hand side. Okay, take notes. When you're ready, you can hit the continue. All right, next proof. Next, let's prove the one that looks very similar to that one. So if you're subtracting 2 logs of the same base, I can change that into 1 log with the number in front of the subtraction on top and the number after the subtraction on the bottom of this division. So from subtraction to division, right? And we're going to start with basically about the same thing as before. So once again, all the letters here are just numbers. So you have some number to E equals some number we're going to call M. Some number to F is just going to equal some number I will call N. If I have B to the E divided by B to the F, that should equal our M divided by N. So that's all I just loaded over there. Okay, and using our laws of exponents, if I am dividing these two, that's the same as B to the E minus F. Next, I'm going to convert these 3 right here into logarithms. This one right here changes into log base B of M equals E. This is log base B of N equals F. And this one right here, log base B of M divided by N equals E minus F, which I just wrote down there. So once again, I'm going to substitute. This E is equal to log base B of M, so I'm going to substitute that in. This F is equal to log base B of N, and I'll substitute that in. And that's what we have. And this is the exact same as that first line up here. The only difference is this side is on the left and then this side is on the right, but it still proves this property right here. Pause whenever you're ready. Hit play. All right, let's prove our next property. So log base B of something to the P power is the same as if the P was in front instead of inside the log. First thing I'm going to do is start with some number B, exponent some number E will equal some number I will call M. So if this side is equal to this side, then that means this exponent P should equal this exponent P. So I'm going to exponent P both of those sides. Using our exponent laws, this right here is equal to B exponent E times P. At this point, I'm going to convert this into a log and that one into a log. So this one converted to log, log base B of M equals E. This one is log base B of this side, MP, is equal to E times P. Now to make this look as similar as possible, I want to switch the order of the E and the P. This is the commutative property of multiplication. E times P is the same as P times E. So that's just me switching the order of the two. Now I know that E is equal to log base B of M, so I'll substitute that in for my E. And here we go. This is our property that we were trying to prove. Whenever you're ready, pause here. Whenever you're ready, hit the play button. I want to go on to a common mistake. A common mistake. So let's say I have this log 12 divided by log 3. A quick note, since there's no number there, this is log base 10, log base 10. So log 12 divided by log 3. One common mistake people do is that they try to use this property on this. They sort of look and they say, oh, look, there's division here, and I see division here, so I can use this one. But that's not actually true. This is not equal to log 12 divided by 3. This is not equal to that. And that's because this does not have that same format. So this one up here is one log of these two things that are divided. Here we have two different logs. So that is not that format, so I cannot use this property. So this is not equal to 12, log 12 minus log 3. So that's one common mistake. Another common mistake that happens is people will see this log 12, log 3, and they'll say, I'm going to cancel the log with the log. And then they'll just say, oh, 12 divide 3. That is also not true. Because this word log is a whole function, it's a whole operation. And log 12 does not equal log 3. Just to prove this to you, here's my calculator. So log 12 divided by log 3 equals 2.261, whatever. Okay, however, let's do this one now. Log 12 minus log 3 equals less than 1. And obviously 12 divided 3 is 4. So this does not equal either one of these. If I wanted to change this in some way, what I could do is I could use this one. So here we have two logs divided with the same base. And here we have two logs divided with the same base. So if I did want to use, if I did want to change these two logs into one log, then this is equal to log base, the bottom one, so log base 3 of 12. Okay, pause. Whenever you're ready, hit the play button. Quickly review changing two logs with addition into one log with multiplication, two logs with subtraction into one log with division, two logs with division into one log with a different base. If you have an exponent to everything inside, you can just put the exponent on the outside. Okay, so after that quick review, let's talk about one more thing. So that very last property we had, which was a review. So you've seen this in the video before, log base b of m equals p is the same as p exponent b exponent p equals m. Okay, using this, we're able to derive or come up with a couple other properties. You don't actually need to know these properties, as you can just use this to come up with it yourself. But because this is true, then log base b of 1 equals 0. And that's because I can write this right here. If I wanted to write this as an exponent, this would be b to the 0 power equals 1. And anything to the 0 power is equal to 1. Using this right here, I can also come up with this other property, log base b of b equals 1. And that's because if I were to write this as an exponent, this is b to the 1 equals b. And yes, anything to exponent 1, it just equals itself.